Hi, in this video we're going to talk about the inverse tangent function. So when you deal with functions, for a function to have an inverse, it has to be a one-to-one relationship, and the graph of f of x equals tangent x is not one-to-one because it does not pass a horizontal line test. If you draw a horizontal line here, you're going to get multiple values of x with the same value of y. But what we typically do in trigonometric functions, because of them being periodic, we can restrict the domain. So if we only take this part of this graph, then we will be able to have one-to-one relationship just for that portion. So the domain then is going to be open interval from negative pi over 2 to positive pi over 2, and the range is going to be for this function from negative infinity to positive infinity. And then the domain of the inverse tangent will be negative infinity to positive infinity, and the range will be from negative pi over 2 to pi over 2. That's what the graph of inverse tangent or arctangent looks like. So let's take a look at problems. What's the arctangent of 1? So what angle on the interval from negative pi over 2 to positive pi over 2 has a value of tangent 1? That angle is going to be pi over 4. If you know your unit circle, you should be pretty easy to answer. Arctangent of square root of 3 over 3. That angle is going to be pi over 6. It's the arctangent of negative square root of 3. On the interval from negative pi over 2 to pi over 2, that value is going to be negative pi over 3. So that should be pretty easy. So when we do compositions here, so arctangent of tangent of pi over 7. So what we're trying to do, if we find tangent of pi over 7, and then we're going to get some value, and then we take arctangent of that, we're going to get back an angle. Is that angle going to be the same as this? Because it looks like one thing can sort of undo the other. Well, yes, pi over 7 is on the interval from negative pi over 2 to pi over 2, so we're good with that. Because sometimes you may think that one thing undoes the other, since these are inverses. Arctangent of negative 2 pi over 5. Well, is negative 2 pi over 5 going to work for us? Is it between negative pi over 2 and pi over 2? And the answer is yes. So this angle here is going to be the answer. So sometimes students start thinking at this point, well, yeah, it's pretty easy. Just take one thing, cancel the other, and you're just going to get the angle that you had there. And it's not always that simple. Arctangent of negative 4 pi over 7. Well, negative 4 pi over 7 is not going to be on the interval from negative pi over 2 to pi over 2. So what do you do with arctangent? So with arctangent, unlike arcsine and cosine, you do it slightly different. Well, first of all, where is that angle? That angle is going to be in quadrant 3, somewhere here. Okay? So what you do is you are going to extend that segment, radial segment here on the other side. And we're going to be looking at this angle and this angle. So whatever that angle is, if you ignore anything about negative angle measures, and this angle is going to be the same. So this angle here is going to be the supplement of this angle when you take it with positive. So if I do pi minus 4 pi over 7, I will be getting 3 pi over 7. So that means that this angle here, again ignoring all the negatives, this measure of this angle is 3 pi over 7, so the measure of this angle here is also 3 pi over 7, and that angle is in quadrant 1, and that angle is correct. So 3 pi over 7. How about arctangent of 2 pi over 3? Well, where is that angle? So 2 pi over 3 is going to be in quadrant 2. And clearly it does not work for us because for arctangent we need to be in quadrants 1 or 4. But 2 pi over 3 is here. This is our angle. So what we do is we're going to extend, just like we did the previous problem, going this way, and we're going to find so that the measures of these two angles is going to be congruent. It's pretty easy to find that the measure of this angle here is going to be pi over 3. because you do pi minus 2 pi over 3, and that's pi over 3. However, that means the measure of this angle here, if we ignore all the business with negatives and positives, is pi over 3. However, we gotta go this way. We're in quadrant 4, so the measure of this angle is going to be negative pi over 3. And our last example here, arctangent of tangent of negative 9 pi over 8. So let's figure out where that angle first of all is. Negative 9 pi over 8 does not fall on the interval from negative pi over 2 to pi over 2, so we're going to have to figure something else out. So this angle is going to be in quadrant 2, which is the wrong quadrant, not the right quadrant anyway, right? But what we're trying to do, we're trying to see, okay, what's the angle that's going to be the extension here. So we're looking for that angle. So these two angles will be congruent. And should be able to see that the measure of this angle here, the measure of this angle here is going to be the same, but the measure of this angle here you can find by doing the easiest way to do it. If you take negative 9 pi over 8 and add pi to it, you will get negative pi over 8. Another way you can do that, you can simply figure out how much more, because this up here goes to negative pi, and the extra going here is negative pi over 8. Either way, the answer is going to be negative pi over 8. Okay, hope this was helpful.